Hello, I am Kishan Debnath and I am a master student at IIT Gandhinagar. So, in this lecture, we will discuss about continuity of a function. Okay, if I am given with a function fx and this is its graph, then what I can say about the limiting value of this function when I tend x to some value c. Let us say this point is c. Okay, if it is c, then okay, I am tending x towards this c from the left side or right side and getting the value of the function towards this point. Say this point is c. Okay, so that means limit when x tends to c from the left hand side. Okay, then I am getting some point, and if I tend x from the right side and getting a number, if these two numbers are equal, okay, if these two numbers are equal, that means they tend to same point, then we will say that this function limit of this function exists at this point c. Okay, so if I say about continuity at this point, then what do you mean about continuity? So continuity is simple. If limit exists at this point c and the value of the function at that point c and their number, all these numbers are equal, that means, okay, if I tend x from left hand side and right hand side and come when we are getting the output here, like let us say here, and this value is as f of c, that means limiting value and the output of this function at this point, all these are same, then we can say that this function is continuous at this point c. Okay, so the formal definition for it, for continuity of a function, we can say if I have a function from R to R, okay, that means it is a real function. We will discuss about real functions. Then we will say that f is continuous at x is equal to c if limit x tends to c at of fx is equal to f of c. If this limiting value and the output of this function at c both are same, then we say that this function is continuous. So if I take an example of it, that where, like, if I take fx as 2x, let's say, then function of 2x will be, graph of the function will be like kind of this. Okay, so I am taking that this is 1 or 2. Okay, so if I take c as 2, then I will get, if I tend x towards 2 from the left side, then I will get what, 2, and in the same way I will get limit x tends to c positive as 2, that means limit exists at 2, and we can see also, sorry, we will get 4. Okay, and finally if I check the value of the function at 2, we will get 4. That means the limiting value and value of this function at 2 both the same, that means this function is continuous at the point 2. Okay, so now we are taking another example let this is a function with this graph, okay, and I am observing at this point C, and if I am getting that the output of this function at this point is here, then the left hand limit and the right hand limit are same, but the value of this function is not same at the limiting point. It is there in the upward, somewhere up in this conclusion. So this function is not continuous. This type of function is called so that means this function is not continuous. Then we say that f is discontinuous at x is equal to c. Okay, so we'll see some we generally get three types of discontinuity. First is like removable discontinuity. Okay, this type of continuity, like if I take this function, okay, fx is equal to x when x is greater than 0, fx is equal to minus x if x is less than 0, and f is like 5, okay, if x is equal to 0. When x is positive, the graphs become like this, and if x is negative, then graph will be this side, okay, and at x is equal to 0, fx will be 5, somewhere here. Let's say this is 5, okay. That means this function, if I tend x towards 0, then the right hand limit is 0, and sorry, left hand limit is 0, and right hand limit is also 0, but the function, the output of this function at 0 is 5 here. That means limit is not continuous at this point, and this type of discontinuity is called removable discontinuity, because we can remove this discontinuity by redefining this function. If I take output of this function at x is equal to 0 as 0, then this function will be continuous. This function of this kind of discontinuity is called removal. After, the second kind of discontinuity is jump discontinuity. I'm taking an example of jump discontinuity. So if I take fx is equal to 5, let's say, when x is greater than 1, and 2 when x is less than or equal to 1, okay. So the graph of this function will be like this. When x is greater than 1, fx is 5. That means if I take 5 here, right, this is 5, then after 1 f is 5, okay, and before 1 fx becomes 2, this, okay. So here we can observe that the left hand limit at 1 of this function is 2, but the right hand limit of this function at 1 is 5. That means limit doesn't exist here. So this kind of discontinuity also, that means this is not continuous at 1. So this kind of discontinuity is called jump discontinuity, okay. And third type is called essential discontinuity. Essential discontinuity. So essential discontinuity means if I take fx as 1 by x, then graph of this function will be this. Okay. So here at 0, if I tend x towards 0 from the left, I will get fx as minus infinity. And if I tend x towards 0 from the right side, then I will get fx as plus infinity. So we are getting infinities when we we are finding the right hand limit and left hand limit. So this kind that means they are not equal, right? So they are also discontinuous. So this kind of discontinuity is called essential discontinuity. So this is all about discontinuity. There are many more advanced topics and concepts here and also. So we'll okay, cut. Now we are going to solve a question. So the question is, if this function is given, then in what points this function is continuous? Okay, a function is called continuous when the function is continuous at every point in the domain. So if I start with the solution, so here we can analyze the whole function, but here we are given with some options. So we'll see about discontinuity at -1, 1 and 0. So I am starting with x is equal to, like, c is equal to 1. Okay, if I take c is equal to 1, then first of all I will check left hand limit. X tends to 1, fx is equal to x tends to n tends to infinity, the whole function. So here we are observing that limiting variables are n and x. So first of all we'll see when n tends to infinity, well, what will happen with this function. Okay, and also observe that here x is coming from the negative side, coming from the left side of 1. Okay, this is 1 and we are coming from the left side. Okay, so okay, one note that if x is power n and n tends to infinity, if we know that x is between 1 and 0, then this limit is always 0. Okay, and if it's not, if x is greater than 1, then this limit will be infinity. Okay, so we'll start with this note. So for that, here if I observe that x is coming from the left side, that means x will always less than 1. If x is less than 1, then this will be 0, and all these terms will be 0. That means limit x tends to 1 negative, these all terms will be vanished. We'll get this function only, this term only. So if I put x is equal to 1 here, we'll get 1. Okay, now we'll see right limit. x tends to 1 positive fx, then okay, let me write the whole function. Okay, so cos 2 pi x minus x 2 pi sine x minus 1 by 1 plus x 2x. So now x is coming from the right side of 1. Okay, that means this time this term will be infinity, like I already noted here. So this term will be also infinity. These all are infinity where power is n is given. Okay, so okay, I'm taking this as common. Okay, then we'll left with this x power 2n cos 2 pi x, and here sine x minus 1. Okay, and here also x power 2n 1 by x power 2n plus x minus 1. Okay, so got it. Now if I tends to infinity, then this term will be 0, will tend to 0, this term will tend to 0, so we are left with this one also. Okay, that means we are left with minus sine x minus 1 and x minus 1. So also this is a note that sine x by x, where limit x tends to 0 is always, sine x by x is always 1. Okay, this result comes from L'Hopital's rule, we can prove later. Okay, so this will become minus 1. So in the previous we saw that left hand limit was 1, but here right hand limit is minus 1. That means this function is not, limit doesn't exist for this function. Okay, for x is equal to c is equal to 1. In the same way we can prove that. So in this lecture we saw the definition of function, and we have discussed about discontinuity of a function at a point, and we solved a question. So this is all about this lecture. Thank you.